Okay, pre-calc class, I am going to try to do a video here for the lesson from last week, projectile motion. I know it was due last week and you all turned it in, but I had a lot of questions on it, so I'm just gonna go over a couple things with it and see how this works so that we can do this for lessons to come. So for projectile motion, we're going to use a parametric equation like we did in the other lesson, and we're going to use it to model projectile motion. So we're like launching something at an angle, and it's going to go a horizontal distance, and it's going to go a vertical distance. So we're going to use x as the horizontal distance and y as the vertical distance, or vertical position they call it. And then we're going to use t and theta, where t equals time and theta is the angle. The gravitational, so the equations are there. X equals t initial velocity cosine theta, y equals t initial velocity sine theta minus 1/2 gt squared plus initial height. So the gravitational constant is the acceleration. So it's going to be 9.8 if we were doing meters per second, or 32 if it's feet per second squared. So for example 1, it says make a diagram of the situation. Mark kicks a soccer ball upward from the ground with an initial velocity of 75 feet. So he's kicking a soccer ball and it's going up and then it's going to come back down. And it has an angle of 62. So there's our angle. And what we know about it is the initial velocity is 75, and our theta is 62, and our g is 32, and our initial height is 0. So you can just take these and substitute them right into the equations to find what you would use for horizontal distance and vertical distance. Okay, so you could simplify those a little bit, especially this part right here. And we could get rid of this 0. So to find the horizontal distance that the ball has traveled into seconds, we're just going to use our horizontal equation right there and substitute in 2 and put all of this in your calculator, and you're going to get 70.42 feet. And if you want the vertical distance, you're just going to take this one and substitute in 2 and put that all in your calculator, and you'll get 68.44 feet. So after 2 seconds, what that is telling us is that after 2 seconds, that is the soccer ball has gone 70 feet this direction and 68 feet this direction. So maybe this right here would be two seconds, and this would be 70, and this would be 68. Okay, so that is what we're doing in these problems. We're using the parametric equations with time and theta to find the horizontal distance and the vertical distance. So let's look at the next one. Example 2, a tennis player serves a ball at an initial velocity of 35 meters per second. The ball leaves the racket at a height of 2 meters and an angle of elevation of 45. So again, whoops, sorry about that. Again, if we draw our picture, now the ball is leaving the racket. It's not down here at 0, it's leaving it up here someplace. So it's going to look like this. It's not starting at 0, and what we know is our initial velocity is 35, and our angle is 45, and our gravity now is 9.8 because we're doing meters, and our initial height now is 2. It's not 0 anymore. So if we want to make our two equations, we're going to say x equals t times 35 cosine 45, and y equals t 35 sine 45 minus 1/2 9.8 t squared plus 2, and we could simplify this part right here as 4.9 t squared. So if you wanted to find the horizontal distance after 1.5 seconds, we're just going to substitute that in. And we get a horizontal distance of 37.12 meters. And if we want our vertical distance, we're going to substitute, now after 3 seconds. So we're not finding the horizontal and the vertical at the same number of seconds. So 3 times 35 sine 45 minus 4.9, 3 squared plus 2. So our our vertical distance after 3 seconds is 36.15 meters. So this we can't put on our graph at the same time because we're looking at different times. So that's what we're working with. Now let's look at some different examples. Whoops, I found the wrong thing. All right, example 3. Now we're going to ask some different questions besides just what is the horizontal distance and what is the vertical distance. Okay, a football is kicked from the ground at a 45-degree angle of elevation with an initial velocity of 60. How long is the ball in the air? So now we're looking for t. Okay, so let's see what we know. We know that theta is 45, and we know that our initial velocity is 60 feet per second. So we know our gravity is going to be 32 because we're dealing with feet, and our initial height is 0 because it says that it was kicked from the ground. So how long is the ball in the air? So we need to know, if you think about a picture, it's kicked from the ground and it's going up and then it's coming down. How long is it in the air? What do we know when it hits the ground, either about the horizontal distance or the vertical distance? The vertical distance, which is y, equals 0 when it hits the ground. So we want to know what is t when y equals 0. So we're going to use our y equation, and we're going to say y equals t times 60 sine of 45 minus 16t squared plus 0 for our initial height. So we don't have to put that on there. And we're going to say, when does this equal 0? How do we solve something like this? This is a quadratic. Usually we use factoring. When you have a quadratic, there's no constant term, so we can factor out a t, and you can get 60 sine of 45 minus 16t equals 0. So either t equals 0 or t equals 60 sine of 45 over 16, which if you put that in your calculator, okay, on your notes that are filled in that I gave you, they did it differently, but I think this is much easier. And you get 2.65 seconds. Okay, on the notes, she used the quadratic equation. There's no need to use the quadratic here since there isn't a constant term. So we have two t's, t equals 0 or t equals 2.65. Okay, here's t equals 0 right here at the beginning, and here's t equals 2.65 when it hits the ground again. So how long is it in the air? It's in the air for 2.65 seconds. Now find the total horizontal distance the ball traveled. So how long did it go this direction? We're going to have to use our x equation, which is this. And we're going to substitute in our t that we found over here. So we're going to have 2.65 times 60 cosine 45, and that equals 112.43 feet. So the ball traveled 112 feet this direction, and it took 2.65 seconds. And at that point, the vertical distance is 0. So in that example, we're looking for t instead of looking for x or y. Now in example 4, a baseball player in the outfield throws a ball towards home plate. The ball leaves his hand at a height of 6.5 feet at an initial velocity of 110 feet per second. So we've got an initial velocity of 110 feet per second, and we've got an initial height of 6.5. And the ball is caught by the player at home plate after 1.8 seconds. If the ball traveled a horizontal distance of 191 feet, find the angle of elevation at which the ball was thrown. So now we're looking for theta. In example 3, we're looking for time, t, and now we're looking for theta. We know that t equals 1.8 seconds, and we know that the horizontal distance, which is x, equals 191 feet. So that tells us that we need to use our x equation. So we're going to say x equals t times 110 cosine theta. We don't know what theta is, but we know that x equals 191. So we're going to set this equal to 191, and we're going to solve for theta. So we're going to say, oh, we also know t. T is 1.8. So I'm going to substitute in oh no, I can't get it to work. 1.8 times 110 cosine theta equals 191. So cosine theta is going to equal 191 divided by 1.8 times 110. So you can put that in your calculator and then use the inverse cosine button. This equals 191 over 198. So then you would say theta equals inverse cosine of 191 over 198. Do that on your calculator, and you should get theta equals 15.28 degrees for our angle. So that's the angle of elevation that the ball was thrown. Okay, what was the height of the ball when it was caught by the player at home plate? So the height is a y. So we need to find a y. And our y equals t 110 sine theta, whoops, minus 16 t squared plus 6.5. Those were all the things that we said we knew at the beginning. And it says, what was the height of the ball when it was caught by the player? Well, it was caught by the player at 1.8 seconds. So we're going to just find y when t equals 1.8. So we're going to substitute 1.8 in here, because now we know theta is 15.28. And we're going to put this all in your calculator, and you're going to get 6.84 feet. And that's how high, that was the vertical distance of the ball when it was caught. And now for the last example, a projectile is fired from the top of a 24-meter tall building at an angle of elevation of 28 degrees with an initial speed of 55 meters per second. So we got an initial velocity of 55, and we've got an initial height of 24, and we've got a theta of 28, and it's asking us for its maximum vertical height. So this is what it looks like. It's starting up here at 24, and it's going off like this and coming down. And we want to know, what is this maximum height right here? That's a y. So we want to know the maximum vertical height that it's reached. So that tells us that we need to use our y equation. So our y equation is t 55 sine of 45 minus 4.9. We're using that because it's meters, plus 24. We want to know when this is a maximum. Well, this equation right here is just a quadratic equation. It's got a t squared right here, and it's got a t, and it's got a constant. It's a little bit strangely written in the order, so I'm going to change it around and write it like we normally do for a quadratic. 55 sine 45 t plus 24. Okay, this is the coefficient for t squared. This is the coefficient for t. This is just a number. And then here's our constant. So to find the maximum of this parabola right here, this maximum is the vertex of the quadratic. So in order to find a vertex of a quadratic, you should remember that in this case, since it's a t is going to equal minus b over 2a. That's how you find the vertex of a quadratic. So in this case, here's b. So we're going to have minus 55 times sine of 45 over 2 times negative 4.9. This is a right here. A is with the t squared, b is with the t. These are all just numbers. Put that in your calculator and you get you get 1.23 seconds. Okay, that's when it reaches its maximum. What is its maximum? You're going to take that 1.23 and put it back into our y equation to tell us what the maximum is. So substitute everything back in. I went back to the original. 1.23 squared plus 24. Put that all in and you get 64.4 meters is our maximum height. To find the horizontal distance traveled when it reached its maximum, we're going to use our x equation. So that's going to be, our t is 1.23. That's what we found for how long it took to get its maximum height. So we're going to substitute that in for t and the other things we know, and we get 47.84 meters is how high it went. So remember what it looked like. It looked like this. It started here at 24. It went up to 64. And when it was at 64, it had gone 47.84 horizontally. That's what we found right there in that equation, in that problem. Now for part C, if the projectile is fired towards a taller building that is 300 meters away, will the projectile hit the building? If not, how far from the building will it land? Okay, so let's see what we're looking for. 300 meters is, just a minute, I gotta look at this. 300 meters is how far it is horizontally. So let's see, there's a couple things that we could do. So let's look to see what it looks like. Again, it's starting here and it's going up and then it's coming down. Somewhere along the way over here, there's a building that is 300 meters away. We want to know if the projectile, doesn't even tell us what it is it going to hit that building? So is the building here? So is this 300 so that it will hit the building before it hits the ground? Or is the building over here someplace and maybe this distance is 300 and it's going to land on the ground before it even gets to the building? That's what we're trying to decide. So we need to know when it hits the ground, is it shorter than 300 or longer than 300 when it hits the ground? So let's see how long it takes to hit the ground. So we're going to say, y equals t.55 sine of 28 minus 4.9 t squared plus 24. Oops, 24. We want to know, when does that equal 0? Now, in order to solve this, you're going to have to use the quadratic. It's not very fun. We're going to say negative 4.9. I'm going to switch it around so that it looks like something that we normally look at for a quadratic. And here's our A, here's our B, here's our C, and we're going to say the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. So you're going to do this all on your calculator and you're going to get 2 answers. You're going to get a negative answer, which is this right here, which we don't want because we're not going to go negative time. And we're going to get a positive answer of 6.08. So it takes 6.08 seconds for it to get to the ground. Now we have to decide at 6.08 seconds, what is its horizontal distance? Is its horizontal distance less than 300? So that it hits the ground before it reaches the building? Or is it more than 300, like this one, so it would hit the ground after it would hit the building before it hits the ground? So we need the horizontal distance, so I'm just going to do it up here. X equals at 6.08 seconds. And it's going to hit the ground at 295.26 meters. So that's less than 300. So it's like this green one. It's going to hit it here at, from here to here is 295 and the building is 300 away. So it's going to hit the ground before it hits the building, and it hits the ground 4.74 meters before it gets to the building. Okay, so I hope that that explains some things a little more. Do you have specific questions from the homework? Let's see. Let's look at the very last one on the homework, number 6 with the football, because that is kind of like the one that we just did. You have to figure out if it hits the if it goes over the post or not. So let's look at number 6 on the homework. A football is kicked from the ground at a 55-degree angle with an initial velocity of 50. So it's on the ground. So it looks like this. And we got an initial velocity of 50, and we got an angle of 55, and we got an initial height of 0. This one will be nice to solve because this tells us right here when the initial height is 0 to solve. If we have to solve a quadratic, we don't have to use the quadratic formula. So that's nice. So what is the maximum height reached by the football? Remember, that is looking for this. The vertex of the parabola. So we're looking for a y value for the maximum height. So we're going to use our y, and our y is 50t sine of 55 minus 16t squared. We're using 16 because these are feet. No initial velocity, so we don't have to put anything there. We have to find the maximum, which remember is minus b over 2a, and this is b, so minus 50 sine 55 over minus 2, or 2 times minus 16. A is negative 16. Put this in your calculator, and you should get 1.28 seconds. So that is how long it takes to get to its maximum height, and its maximum height is, substituting it in, its maximum height is 26.21 feet. Find the horizontal distance traveled when it reached its maximum. That's an x. So we're going to use, we know it took 1.28 seconds. So then we're going to multiply that by 50 and cosine of 55, and that equals 36.71 feet. So it went 36 feet here horizontally and 26 feet vertically at its maximum. If the ball was kicked towards a 10-foot goal post that stands 70 feet away, will it pass over the post? And if not, how much higher will the ball need to go? So there's a couple ways you can do this. This is how I'm going to do it a different way than I did the last one. The goal post is 70 feet away horizontally. So I'm going to take my x and I'm going to say 70 equals t times 50 times cosine of 55, and see how long it takes for the ball to reach the 70 the goalpost that is 70 feet away. So if I solve this for t, I get 2.44 seconds. It takes 2.44 seconds for the ball to get to a goalpost that is 70 feet away. So let's see how high the football is at 2.44 seconds. So we're going to use our y. And it is 4.68 feet at 2.44 seconds. If the goalpost is 10 feet high, will the ball pass over it? No. because it is not, it's not high enough. It's only 4 feet high, and the post is 10 feet. So how much higher would the ball need to be? We're just gonna take this and subtract it from 10, and we'll get, it would need to be 5.3 feet higher. Okay. So there are some examples for this lesson. See if you can do the problems that are on the study guide and the test with these types of problems, and let me know if you have any questions, and also let me know how this video worked, and if you think this will work for me to explain things once we start the next chapter. So just let me know, and I miss you guys, and I hope you are having a fun time at home.